First of all, we're going to write the entire series in ascending order. Then we're going to multiply each of those terms by r and write that underneath. And then we're going to subtract the top one, subtract the bottom one. And then at the bottom, we're going to solve for Sn, just like we did with the arithmetic series. This is what it would look like if I use numbers. This is not the proof, it's just an example, sum to 4 terms, and I'm making it up. So let's say it's 4 with a constant ratio of 3, so we multiply by 3 each time, and those are the first 4 terms. Okay. Now what I'm going to do is multiply that by 3. So I'm going to say, well, because r is 3, okay, so perhaps I'll just write it over there. In this case, r is 3. So I'm going to take the S4 and I'm going to multiply it by 3. So I'm going to say, okay, what's 3 S4s? And so now each term is going to get multiplied by 3. So that's going to be 12. Look at what's happening here. That's going to be 36. That's going to be 108. And that's going to be 324. Look what's happened here. Let me write it with a space. Let me not write that 12 here. Let me put it here and make it really obvious what's happening. This is a good way to construct these things so that you can really see what you're doing. Okay, so if I subtract them, which is what I'm going to do, obviously I'm going to get 4 here because there isn't a 4. But do you see that when I subtract all the others, I'm going to get 0 except for the last one, which in this case is the 4th term. It's T4, but it would then be Tn if it was all the things with variables in it. So that's 0, that's 0, that's 0. 0 minus 324 is going to be negative 324. Okay, so that on this side, what I did was I took S4 and I subtracted 3 S4s. Okay, so now I've done those 3 steps and I've got to solve for Sn. So if I have 1 S4 and I minus 3 S4s, I've obviously got negative 2 of them, right? So negative 2 sums to 4 terms. When I put those together, I'm going to get negative 320. Okay, and now I'm going to solve by dividing by negative 2. So the sum to 4 terms is 160. Okay, so what I'm doing works. If you add those up, if you take 4 plus 12 plus 36 plus 108, you're going to get 160. So I guess doing this with numbers is just a way of proving that when we do it in a generalized manner, it actually works. So now, if I'm going to take it and I'm going to use R's and SN's and N's in it, then you can trust the fact that that proof is actually going to get us somewhere that's going to help us find not an answer, but a formula to use to calculate the geometric series. Okay, so the same steps as last time. We're first going to write the series in ascending order, but this time it's going to be sum to n terms. Okay, now what was my first term? My first term is a. Okay, and then my second term is going to be a, but it's the one we have times by r, so my second term will be ar in terms of a and r. Okay, my next one is going to be ar times another r, so it's going to be ar squared. You see where this is going? Okay, then I'm going to have ar to the 3, and it's going to keep on going until I have ar to the n minus 1. Okay, so our tn term, our last one. Right, so the next step is to multiply all of these by r. And I want to remind you of what I did when it was numbers. I wrote it all out, and then the second time I actually shifted them all to the right because they're going to end up being the same. So if I now take r times Sn, and I times a by r, I'm going to get ar. So let me just leave that blank as a tactic to help myself see that all of these are going to cancel. If I times that by r, I'm going to get ar squared. If I times that by r, I'm going to get AR to the 3. Okay, so you can see when I subtract them now, they're going to fall away. All of those will also cancel. And then the next one before this one, when I multiply by R, I'm going to have AR to the n minus 1, sure, but then I'm going to have this guy multiplied by R, and that one's going to be AR to the n. Okay, so now when I subtract, you can see how this is going to work. Here, I'm going to have 1Sn minus RSn. So let me take out a common factor of Sn. I'm going to stick it on the right-hand side. And I'm going to say what I've got here is 1 minus R of Sn's. Okay? And then, obviously, these guys will all cancel each other out when I subtract them. So here I'm going to have a whole bunch of zeros here. Okay, you can put those in. I will. I'm just going to stick all the zeros in. Those will all become zeros, but I will be left with A. And here, these guys will now cancel, but I'm going to be left with AR to the n. Okay, so tidying that up quite nicely, I'm going to have 1 minus R of Sn, and I'm going to have those guys, but they've also got a common factor of A, so let me take out the A, and I'm left with 1 minus R to the n. Okay, my last step was to solve for Sn, so that's multiplied, so I need to divide it on both sides. So I've got Sn, and then I've got A, 1 minus R to the n, over 1 minus R. Similarly, this can be done the other way around. I could swap those and then swap those at the bottom to get the other formula, but that would just be taking out a negative 1. I'd end up with negative here and then R to the n minus 1, but then there'd also be a negative here, and that would be R minus 1. The two negatives would cancel, and I would end up with the other formula. So I would end up with a R to the n minus 1 over R minus 1. Okay, so that could be manipulated if you need it. The one caveat we must understand is R obviously can never be 1, because if it is, then you don't have a geometric series.